Have you ever wondered why a pencil looks bent when you dip it in a glass of water? Or why the world looks different through the lens of a pair of glasses? The answer to these questions lies in a fascinating phenomenon known as refraction. Refraction is a fundamental concept in the world of physics. It's the bending of light as it passes from one transparent medium into another. But what causes this bending, you might ask? It's all down to a change in the speed of light as it transitions from one medium to another. Imagine light as a series of waves traveling through space. When these waves hit a boundary between two different media, like the surface of a pond, they change speed. If the light enters the new medium straight on, it continues in the same direction but at a different speed. However, if the light hits the boundary at an angle, it also changes direction. This shift in direction is what we perceive as the bending of light. The degree of bending, or refraction, is governed by a principle known as Snell's law. This law relates the angles of incidence and refraction to the refractive indices of the two media. A medium's refractive index is a measure of how much it can bend light. Refraction isn't just an abstract concept, it's something we experience in our daily lives. Consider a straw in a glass of water. The straw appears bent not because it's physically deformed, but because the light from the straw refracts or bends as it moves from the water to your eyes. Or take the example of a fish in a pond. The fish appears to be in a different location than it actually is. This optical illusion is due to the refraction of light as it travels from the water into the air. Another everyday example is the use of lenses. Whether in eyeglasses or a camera, lenses use the principle of refraction to focus light, enabling us to see clearly or capture sharp images. Even the beautiful spectrum of colors displayed when light passes through a prism is a result of refraction. The prism separates white light into its constituent colors based on their different refractive indices. And let's not forget the mirage in the desert. The hot air near the ground has a lower refractive index than the cooler air above. This difference causes light from distant objects to refract, making them appear displaced or even inverted. In summary, refraction is the bending of light due to a change in its speed as it passes from one medium to another. This bending is governed by Snell's law and is influenced by the refractive indices of the media involved. From the apparent bending of a straw in water to the formation of a mirage, refraction is a phenomenon that shapes our perception of the world around us. So, the next time you spot a rainbow or put on a pair of glasses, remember, it's all thanks to the wonder of refraction.